Up to this point, we've been talking about completion stage methods that handle the normal results of processing. You start some asynchronous computation, like creating a random big fraction, and then after that finishes, you have some things to apply to multiply it or reduce it or print it or whatever. That's the so-called sunny day scenario, or the happy path, when things go well. We're now going to turn our attention to what happens when things go wrong. And we'll start off first by discussing the subtle differences between synchronous exception handling, which is what you've probably been familiar with up to this point, and asynchronous exception handling, which you are probably not as familiar with unless you've programmed with something like completable-futures before. And then we'll also give an overview of some of the methods that are in the completable-futures exception handling bin of methods. So let's first start by talking about synchronous versus asynchronous exception handling. Exception handling is more complicated for asynchronous computations than for synchronous computations. And maybe a better way to put it is it's not necessarily more complicated, it's less intuitive if you're familiar with the classic way of handling exceptions. So let's first quickly summarize that classic way of handling exceptions. So the classic way of handling exceptions, or the conventional way, is to propagate the exceptions once they're thrown, or an exception once it's thrown, up the runtime call stack synchronously. So what the heck does that mean? Well, let's take a look at an example. So method 1 is called, so it's going to call a bunch of methods. Method 1 we'll call method 2, which we'll call method 3, and so on. And at some point, somewhere down that call chain, some method, let's say method 4, will throw an exception. In this case, it's going to throw an IO exception. All right, so what happens then? So what happens then is the Java runtime will search up the call stack to find some exception handler that can handle that particular exception. Now, if it never finds an exception handler at all, the thread will exit and you'll get the uncaught exception handler message, which is pretty severe. I think it will shut your program down if you don't do something to the contrary. But bottom line is, if something goes off the rails, that thread will go away. In this particular case, let's say for sake of argument that method 1 had an exception handler and it catches the IO exception. So far, so good. So the thing to remember with synchronous exception handling, with the conventional way of doing things, the thread that calls a method is the same thread that can handle any exception that's thrown in that method, if it so chooses. It doesn't have to do it, but it can. And the calling thread and the catching thread and the throwing thread are all the same thread. And that's a really important thing to remember. In contrast, asynchronous computations using completable futures don't conform to this conventional call stack model. Why is that, you may ask? Well, one reason is because these completion stage methods run deliberately in different worker threads than the thread where the method call originated. So the thread that initiates the asynchronous computation is not the thread that's running the computation. If it was, that would defeat the whole purpose of completable futures, right? Which is to try to have things running concurrently and asynchronously in the background. So this leads to all kinds of weird, quirky things if you don't think about it and you don't design APIs to handle it. So let's say, for sake of argument, here's thread 1, and it invokes method X asynchronously using supply async or something like that. So thread 2 now is running method X. And thread 2 can throw an exception because something can go wrong. And now thread T1, or thread 1, is in a completely different context. It's gone off and called method 2, which called method 3, and so on. And so when thread 2's method X throws an exception, thread 1 is in no position to handle that because it's doing something totally different. It's not waiting for that exception to come back. It doesn't even really know that that's happened. It's running in a background thread. Of course, thread 1 can still handle synchronous exceptions just like it did before, right? It can have a handler that will catch an exception if it's thrown. But what we're really concerned about is what happened to thread 2's exception. And we don't want it to just disappear. That would be missing the point. So somehow we have to arrange that thread 2's exceptions can be caught and handled somehow. So let's talk about how that's done in Java and the completable futures framework. So there are these exception methods that are effectively completion stage methods, but they don't handle the happy path. They handle the error path. And they handle exceptions that can occur asynchronously. And there's 3 different categories of these things. And you'll see that there's variants of all of them, of course. So let's talk about them one at a time. One exception handling method, and I'm using air quotes here because it doesn't really handle the exceptions, but one method that can be used to do something if an exception occurs is called whenComplete. And it takes a by consumer parameter, and it'll return a completable future with the results of the earlier stage, or it'll throw an exception. And this is very important. It doesn't swallow the exception. So what you can do with whenComplete is you can differentiate between the normal path and the error path. And you can do some side effect in either case. But the key point there is it's a side effect. Nothing is changed. It just has the side effect of giving you a hook to detect that there's an issue. The next set of exception handling methods are called handle, which is kind of a lame name, but it's called handle. It takes a by function. So unlike, unlike by consumer, which has no results, by function has a result. And so what you can do with handle is you can actually perform an action that could, in fact, change the results that come back. And typically what you do here is if you get the normal processing, you just kind of pass the results along. But if you get an error in the handle hook method, then you typically create a new value. So handle can be used to convert an error into some sensible value that can then keep the chain running so it doesn't stop. So this basically swallows the exception. And then finally, we have something called exceptionally, which will only catch exceptions. It's ignored altogether if the normal processing goes as usual. But when an exception occurs, the exceptionally method can be used to replace the exception with some result value. So in some sense, it's a little bit like a catch clause in a normal synchronous exception handler, except it is running asynchronously. And all of these particular method groupings help make programs more resilient by handling erroneous computations gracefully some way or another. I should also point out in Java 12, they added an async variant for exceptionally. There's also async variants for whenComplete async and handle async. I'm probably not going to use those a whole lot, but they do exist. So here's a summary of the capabilities of these different groupings of exception handling methods. So as you can see, here's handle, whenComplete, and exceptionally. So do you have a success path? Can you get access to the value if things succeed? For handle and whenComplete, the answer is yes. For exceptionally, the answer is no. Do you get access to the failure value? They all have that. Can you recover from failure? So handle can recover from failure, exceptionally can recover from failure. whenComplete cannot recover from failure. It just can log something, note it somehow. Can you do any transformations of the results? So handle can transform the results, exceptionally, and whenComplete can't. And by transform the results, it means transform the type of the results. Is there a trigger when success occurs? Yes, for handle and whenComplete. No, for exceptionally. Is there a trigger when failure occurs? The answer is yes for all of them. And is there an async version? And the answer is now, as of Java 12, yes. I'll just note, not that it really matters, for Android Studio, Android only supports up to Java 11. So they don't have the exceptionally async variant yet. Not that it makes that big of a deal, but it's just something to note. OK, so that's the end of our discussion of the first part of our discussion about how to handle runtime exceptions in completable futures.